Okay, hello students. Here I'm in this video. I'm trying to solve. Uh, this is Unit 5, lesson number 2, and there are just 5 problems, practice problems. So here it is, 6 problems. So let's go and directly work on it. The first one is so make sure you write all the notes. See how understand the question. So if this is the first question, read the whole question first before you try to attempt. Let me read this question. It says. Uh, so, so the thermostat in an empty apartment is set to 65 from 4 a.m. to 5. And so this part, what does this mean? It set from 4 a.m. to 5. So this is that 4. Okay, so this is exactly 4. And this 9, 5, this 8, this number, even that's the 17. And what is 17 p.m. basically means it is uh, 5 p.m. That's sort of so just from 4 a.m. until 5 p.m. It's set to 50 degrees, and you can see it's 50 degrees. Uh, so even though it shows you, so this is where he sets up the thermostat to 65. That means the temperature rises. This is where the temperature rises and becomes 65. And then exactly at 5 p.m., that's the 5 p.m. It's put off, and then the temperature goes back to 50 degrees, which was in the beginning. See, this was 50, this is 50, and in the beginning it was 50, 50. But at 4 o'clock, he starts, and then the temperature rises, and then remains 65 until 17, and you put it off and goes down. So this is what is shown here. Let's see. So what is the question there? Okay, so the question is, the owner of the apartment decides to change to a new schedule and they set the thermostat to change 3 hours later. This is the most important word, 3 hours later in the morning and evening. So that means the whole graph. So this is 50. So this will have to move, this point will have to move 3 hours later. So let me use this thing. Okay. And then let's see. So this goes all the way until here till 7, and then this point will go 3 spaces. So from here to here. So what I'm gonna do is this will rise and go exactly this way. Okay. Then it will remain 65 until 3 hours later till 8 o'clock. The 20, this 20 which you see, this 20 means 8 p.m. and then it goes down, and that's how the new sketch. So the graph, so this is H graph, the black color. This is the new graph, which is the G graph. So the blue color, the G graph, this is the new graph, X uh, X minutes from X hours from the beginning, from 12 night. So hope that helps. The first part is done. So the main thing, are you able to sketch? So the blue graph is just a translation of the original graph shifted 3 units to the right. Next question is, explain what does this means to you, so in the context. So that means what is 6.5, right? So I'm going to write it right here. 6.5 hours means it is 6 hours and plus 0.5 hours, right? So 0.5 hours means 6 hours plus uh, this 1 hour has 60 minutes, so you multiply by 60, and when you multiply by 60, you get 6 hours and 6 hours and 30 minutes. So that means, what does this mean? So after 6 hours and 30 minutes, the temperature is, so here you're going to write after 6 hours and 30 30 minutes, the temperature, so you can write the temperature, the hours, the temperature of the room is 65 Fahrenheit. So that's all that means. And now at that point, that means, where is this? So now let me locate this point using, so 6 hours 30 minutes will be this point. What's this? So this will be 6 hours 30 point. Okay, so that's the point. If I go all the way, go down, let me see if I can try this point, and go from here. Oh no, I think I'll have to use this part. Let me use this, so in this part. See, this is 6 hours 30 minutes, and you can clearly see the temperature right there is, this point is in the middle is 6.5, when 6 hours point 5, the temperature is 65 degrees. Now, the next question is, if that's the correct, okay, is if after if six, around 6:30, the initially the temperature was 6:30, what is the corresponding point on G? So the blue graph. So now we have to go on the blue graph. So the G is this point. So that will be after 3 hours. So now I'll have to move from, this is 6.5, that's 7.5, then 8.5. So it will be 9.5. So this is going to be 9.5. And that point will be somewhere here. So this will be the corresponding G graph, the temperature. So what are we supposed to write here is G, G of, because it is at 9.5, so G of 9.5 is is 65 degrees, because the same height. Look at the same height. It's the same 65 degree here. So this is 65 degrees. So that's what the meaning of the corresponding G. And then the next question asking is, write an expression for G in terms of H. So how do we do it? Write this part. So whatever we got this, now watch this. This G of 9.5 is 65, but that 65 was, this was H of 6.5. So this is H of 6.5. And this we can write as, so G 9 hours 30.5 is H of, and this 6.5 we can write again the same 9 which you see here. This 9, which is 9.5, we can write 9.5 subtract 3, because 9.5 minus 3 is uh, this 9 is this 6.5. So we can always write. So the goal is to see that 9.5, this red color 9.5 is repeated here. So that means for any time, that means now we can write down. So G of, at any time T after midnight is same as the temperature of the room 3 hours later is same as H, the temperature 3 hours before. That means T minus 3. And that's the formula, which is very important. And I hope that helps. Let's go to the next one. Again, read the question. The second question says, a pumpkin pie recipe says to bake the pie at 425 for 15 minutes. This is important information. So, so it may be the temperature of the, in the beginning of the oven. Now we are talking about oven temperature, right? So you set up, so thermostat, so you set up that temperature to 425 for 15 minutes, and then to adjust the temperature down to 350 for additional 45 minutes. Now P is the function. What is P stands for? It's a temperature, T minutes after the pie is placed in the oven. So when the pie is opened, how many minutes pass? So P stands for the temperature after. The question is, explain what does this means in the context. You have to write in your own English words now. Only thing I want to show is here you have to understand what is the meaning of PT. This means it's the temperature in degree Fahrenheit T minutes after the pie is placed in the oven. So if I write this, that means there is a 30. So instead of T, you see there is a 30. So you say, okay, 350. Or you can say after 30 minutes, 30 minutes after the pie is placed in the oven. So it's better to write. I don't know, I'm able to write here. Let me try. I'll take a small number. So that means after after 30 minutes, after 30 minutes, or you can say 30 minutes after, that's better English words. 30 minutes after the pie is placed in the oven, the temperature, the the oven temperature, the oven temperature is 350 degree Fahrenheit. Degree and Fair, Fahrenheit. Makes sense? That's all you're supposed to write here. 6 is for nice and nine. 30 minutes after the pie is placed in the oven, the oven temperature is 350. The second question is asking you is Diego discovers that the temperature inside the oven is always 25 degrees warmer. It means warmer. What does this warmer mean? More than the oven's temperature setting. So one thing is you setting the temperature that you see, but actual temperature is always 25 and that is defined by B. So the new function inside the oven is the actual is given by B, gives the actual temperature of Diego's oven. So if this is the answer, whatever that P, the whatever you show, which you see, not the actual oven temperature, but the setting up which is done, then what is the corresponding point on the function B? Oh, what this means so this basically means is the oven. Now let's see. Now this is the oven. Okay, this is the oven, and let's see, this is the oven, and maybe on the setting you see the temperature which is seen is 350 after 30 minutes. So here you see 30 minutes is 350, right? 350. But actually inside that oven, the temperature is always 25 degrees more. That means if this is after 30 minutes, if this is the answer, the actual temperature, so B, B of 30 minutes after the pie is placed in the oven, the temperature will be whatever the setup is 350, but then you have to add this 25 right here, which becomes equals to 375 degree Fahrenheit. That's what B30. So what is B30 stands for? Is the actual. So it is the actual temperature of the oven. So B30 is the actual temperature of the oven. And this P30, what is P30 is what you see when you set it up. So this is what you see when you set it up. But inside is different, it's 30 degrees more. So basically the last question is how do I write this in terms of P? So the inside temperature is higher, so I put B of T maybe temperature equals whatever the temperature of T of the whatever you see right here, that is T, and then plus 25. So basically this is the main important formula. So no matter what, even if I say that If I say 50 minutes, so what does that mean? It is B of 50 minutes is P of 50 minutes, whatever you see in the setup, plus it has to be 25 because this is the actual insider temperature. Hope that helps. Let's go to the next question. So here the question is says, here's the graph of, you see the black color graph is clearly sees. Now on the same x-axis in the grid sketch, we are supposed to sketch another graph G. So the new function has to be drawn. By just looking at it, you have to sketch something that is whatever the original f of x, that's the main one, but then there is a plus 2. So what does this plus 2 basically mean? The output is added to. So each time you add plus 2. So if this is the graph, so this 2, this 2 will move two places up. So you go 1 and you go 2 to this part. So that moves right here. Then I can think of this point, which is almost like, it's like maybe in 1 and negative, I don't know. Maybe that point will move two places up. So this will go just somewhere here. And this point will go two places up. So from here to here. So your new graph would be, so your new graph will be something like this. So that will be the graph for the A part. So you're supposed to sketch this. So, and the B part says on the same axis, graph f of x plus 2. So what is this f of x plus 2? Let me wipe this off. This we solve. Now this is the most interesting. What does this basically means? So h of x, that means the new graph that is you're going to graph has to be whatever the output of the first, uh, and that happens 2 units afterwards. That means we need to go to the left side. So let's see if this is the point, so this point, because there is a plus 2, I have to go to, can I write this? Go to the left. So this goes to the left here. Okay. Everything goes to the left. This go, can I use some other color here? Let's see, green color. So this goes here. This goes here. So, and this point, which is, it's not exactly like, I don't know, maybe this point, maybe somewhere here. So two, that's too long, so I can shorten it maybe this point, maybe here. Yeah, and now you have those points. So you have this point, and you have this point, and you have this point, and you have a graph. I'll use the blue graph for this one. So you can clearly see the output. Let's see this output and now this output. That means this is h of 0 is f of 0 plus 2. That means the black one that you see here, this black one is the output of the black. This one is 2 minus 4. So both have the same. This also is minus 4. This also is minus 4. So that's 0 minus 4. So both have the same output, but then the black graph is 2 units later. And that's why I say there's plus 2 here. So this is the answer. So you're supposed to sketch the graph below. So main thing is the graph shift. So how do the graphs f and g compare? So in this case, this graph is translation of the black graph shifted 2 units to the left. And the other one, which I think I wiped off, and it was going 2 units up. So this is plus 2. So the one. So that was the translation. So the G was the translation of the black graph, which is shifted 2 units up. So, question number 4 says the function. So they give you a expression like this. Look at this. Clearly shows you F2 is 5 plus 30 feet, 30 minus 32 feet. Model the height of a ball in feet. How high was the ball when it was hit? And where do you see this in the equation? If you see the ball, the graph over here, it starts. It starts. That's where at the height of 5 feet above the ground, the ball was being thrown in the air and it goes up parabolic. It takes a maximum and that goes down. And then after 1 and some second, it falls down. So the question was, how high was the ball? So it's the y-intercept when x equals 0. So this point is when 0, before the ball being thrown, it is 0 and 5. Where do you see in the picture? It's the y-intercept. On the graph, you see that it's the y-intercept. Suppose the second ball is being follows the same trajectory, but it is hit 7 feet off the ground. So there is another ball is being thrown, but this time you throw 7. Now 7 will be, this will be 6, this will be 7. So that's like 7. So you throw the ball here. So what's going to work is with the same expression now. Here, so it says it doesn't tell how fast the it means the ball is thrown with the same speed. Now, I just wanted to make sure to understand what is this 30 t. It means the ball is thrown in the 30 feet per second, the speed of the ball. So this is like every second the ball travels 30 feet. Now, what is this 32 feet means? That means the gravity of the earth pulls the ball downwards 32 feet per second square. So every second the ball is being pulled down by 30 feet. The speed of the ball is reduced by 32 feet per second. So that's why there is a deceleration. When you throw something up, then that means the gravity is pulling it down, reducing its speed instead of going up. But then, because you are throwing the ball at the same speed, so this also, no, I'm going to use, maybe I can try this graph. What is- So this goes to up like this. So that's all it is. Look at this, so beautiful. So what I'm supposed to do is write an equation. So write an equation. So we sketch the graph of the height of the second ball. That's the blue one. Write an equation of the function g that defines the height of the second ball from 7 feet off the ground in terms of ft. So you can see the relation between here. At this point and this point, so this point is, so this point is goes up, this point is going 2 feet. So every time it's going to be going up to, let's say there was a height here of the original, then it goes, so everything goes to. So what you have to do is write down here, that means the second part. So the second part is given by gt. So gt is the original f of t and you add plus 2. But if you want to actually know the actual expression, you can plug this in and say, okay, that's 5 plus 30t minus 32 feet t square and plus 2. And then this 2 and this 7 adds to 7 plus 30 feet minus 32 feet per second square. That's the expression for gt. So all you see is this 7 is where the y-intercept, where the ball is being thrown in the air, and that's how it is. And I hope that works. So this is from lesson number 1. Again, it's just a review. Describe a horizontal translation of the line to a line that contains the two labels. So you see, these are the two label point -4 and now first is let's do the horizontal. So this one is the given line, and we need to move this translation. I'm going to take this point, so this point, and move this to this point. So let me use this thing. Mhm. Use some color. So from here you go all the way. So that's a horizontal translation of 1, 2, 3, 4, 5, 6, 7, 8. So you move to the left. That means that blue graph that you see, so the blue graph that you see, this one, so this is the main graph. That is shifted. See, that is shifted like this, correct? So this is what the graph is. And then I also want you to write, maybe I want to name this is something, maybe this one, which is, let's put it as f of x and not f, g of x. This was the original f of x. So we can say, hey, g of x, the new one is, it is the f of x, the original, but shifted to the left. So we write x plus 8, and that's it. Then there's another one we can think of is the maybe the red color. I'm going to use the point, this point, because he's talking about the vertical translation. So that goes to get this point. I use, this time going to use maybe, well, let me use the green color. So this goes from here. I'm going to use, okay, yeah. So it goes, you see. So how many units does it go? One, you see it is 1, 2, 3, 4. It goes 4 units up. So this graph, which is, let's say this is the graph, okay, and that graph is shifted 1, 2, 3, and 4. So that goes. So the new equation will be, you can write, let's call that is h. So let's call that is hx. So h of x. So h of x is the old one, which is the original. That's the blue one, f of x, and then you're adding plus 4. This is the 4, right? So everything goes 4, 4, 4, 4 up shift. So this is the new equation, and that's the new equation. Hope that helps. And make sure you write all the steps, and we'll go to the next lesson next time. And hope that I made sense to you. So take care, and just remember this one thing is his bottom line is what we learned here is in all this. I just want to show in brief is there is a graph like this, okay, and this is f of x, and you want to write what is the meaning of f of x in a new function. G of x is f of x, let's say minus 4. It only means the graph goes 1, 2, 3, and let's see, this is 4. So it goes something like this. That's it. That's all it means. But if I write h of x and you write f of x plus 5, let's see. So that means the whole graph that is the blue, the green graph, this is the green graph, everything goes to the left side. So if this is the point, let me write this. So this goes 1, 2, 3, and 4. That point goes this way. This will go 1, 2, 3, and 4. Maybe one point here is 1, 2, 3, and 4. So it's like this. Okay? So the same thing, but shift 4 units to the left. So the new graph that is maybe h. So this h is the original f of x, but plus 4 because you're moving to the left. Huh. So hope that helps, and get ready for the quiz on Friday.